Good afternoon, students. So, coming to the topic is effect of substituents. That means the benzene is already having mono one substitution. If it is depend upon alkyl group or activating group or deactivating group, it can direct the position next substitution to the either ortho or para substitution or meta substitution. If the activating groups are present, electron richer groups are present, it can donate electrons to benzene ring and activates the benzene ring, so it can direct the ortho para substitution. If the electron withdrawing groups are there on benzene ring like NH3 plus, NHCO, CS3, these compounds takes electron from the benzene ring, it can deactivate the benzene ring. So the substitution can be takes place at the meta position. So that is about the effect of substituents. See here, when an electrophilic reagent attacks a monosubstituted ring, a group that already attached to the ring determines the reactivity and also orientation of substitution on the basis of these two characteristics. What, whether activating or deactivating. See here, already benzene containing one electrophilic substitution, it is there. So it can direct the another substitution whether at either ortho position or para position or meta position. So if the activating groups are present, they can direct ortho and para. So the type of groups these are called, if the activating groups are ortho para directors. Activating groups makes benzene ring more reactive towards electrophilic substitution. The substitution occurs at ortho and para position. Like examples are NH2, NHR, NR2, OH, NHCOR, OCOR, R, AR, CH double bond, CR2. Mainly N is having lone pair of electrons. N is having lone pair of electrons. O is having lone pair of electrons. So these are the more activating groups compared to this NHCOR, OCOR. They are somewhat deactivating. So coming to deactivating and meta-directing groups, deactivating groups means makes ring less reactive than benzene towards electrophilic substitution. This substitution directs the second substitution to the meta position. Like C, carbonyl group containing compounds. O is totally electronegative. It always takes electron from the benzene ring. CHO, COR, COR, COH, COCl, cyanide, SO3H, NH3 plus. That lone pair is not present, it is positive charge, NH2R plus NH2R plus NR2 plus NO2. These are the deactivating groups. They can direct to the meta position. The substitution takes place at the meta position. And the third one is a very different one. These are the deactivating. That means they deactivate the ring. They take electron from the benzene ring. But they can direct ortho and para. So that is a different class of compound, that is mainly halogens like fluorine, chlorine, bromine, iodine. The substituents makes the benzene ring less reactive towards electrophilic substitution but directs the second substitute towards the ortho position and para position. So these are the deactivating, but they can direct the ortho para position. So coming to the activation and deactivation. What is activation? Monosubstituted benzene, like benzene undergoes electrophilic substitution due to the presence of delocalized pi electrons sextet. The rate of determining step of electrophilic aromatic substitution, attack of electrophile and the aromatic ring, and there is a formation of rhenium ion as we discussed in the last class. That is the main important step. Increasing the electron density of the benzene ring increase the electrophilic substitution reaction property. The substituent that withdraw electron that decrease the rate of electrophilic substitution reaction due to withdrawal of electron from the benzene ring. These are two ways by which substituents by which electron withdraw from benzene ring, that is inductive effect and resonance effect. The first one is inductive effect. In this effect, the electrons in bond that attach the substituents in ring may move either towards the benzene ring or away from benzene ring than the electrons that bonds a hydrogen to the ring. Donation of electrons to the sigma bond is called inductive electron donation. That is mainly alkyl substituent donates electron by inductive than hydrogen. Withdrawal of electron from sigma bond is called inductive electron withdrawal. So that is electron donation or electron withdrawal. Example is NH3 plus. That means if the benzene is having CH3 group, that is toluene. Benzene containing CH3 means CH3 is a electron rich of molecule. CH3 gives electrons to benzene ring. How? Means by the inductive effect. By the simple sigma bond only. It can give sigma bond, only single bond direction, it can give electrons to the benzene ring. So it is called electron donating by inductive effect. Coming to NH3 plus is electron withdrawing property. How it can take electron from the benzene ring means by the sigma bond only, and it can withdraw from the benzene. So that's why we can say inductive electron withdrawal. So resonance effect means if a substrate has a pair of non-bonded electrons on the atom directly attached to the benzene ring, these electrons can be delocalized into the ring through p orbital overlap. Such substrate donates electrons by resonance, like NH2 and OH. Example, NH2 group is present, amine, aniline, benzene containing NH2 group on the benzene. What happened? N is having lone pair of electrons. That lone pair of electrons are given to the benzene ring by the double bond formation, not by single bond. If the double bond by the p orbital overlapping double bond formation, electron is donating to the benzene ring is called the resonance effect. The electrons are donating by the single bond is called the inductive effect. So a substrate attached to the ring that is doubly or triply bonded to a more electronegative atom, that electron withdraw from ring can be delocalized on substrate. Such substances withdraw electrons by resonance. For example, carbonyl group, C double bond O, C triple bond N, NO2. They can take electron from the benzene ring by the double bond formation. Here is taking, withdrawing, that is resonance withdrawal. In the first step, resonance donating. So by the double bond formation, it is by the lone pair of electrons overlapping, p orbital overlapping, the electrons are withdrawn or electrons are donated. That type of condition is called the resonance effect. Electrons are taken by single bond or donated by single bond is called the inductive effect. So they are the examples. The activated substrate donates electrons to the benzene ring either by inductive resonance stabilizes intermediate rhenium ion and decreases improves an electrophilic aromatic substitution. The deactivating groups from the other hand remove electrons by inductive and resonance effect, and these stabilize the intermediate rhenium ion. Thus these are decrease the electrophilic aromatic substitution. So here is the question is why activating substituents are orthopara directing and why deactivating substituents are meta directing. So when the question comes like this, we can answer in this format. So activating means that is alkyl groups, amine, OH. Alkyl is by inductive effect. Amine and OH is lone pair of electrons are present, they can by the done by the resonance effect. Okay, if these groups are present on the benzene ring, but why it can direct ortho and para? Why not meta? Means the carbocation found due to ortho para attack due to hybrid of 4 structures, where hybrid of only 3 structures during meta attack. The results hybrid carbocation formed during ortho para attack is more stable because it requires less reaction in rate determining step. The contributing from 1 2 3C are particularly more stable. Every carbon atom is octet. No such corresponding forms are possible for meta isomers. The positive charge will form 1 and 2 and spread over a larger area including the substrate, and also lowers the energy in comparison to the metamer. All these leads to the conclusion substitution having unshaded pairs suited on atom attached to the ring always gives stable carbocation and also activates the reaction. So this all these things simply explains what is that. If the group like NH2 is there, that is activating group, it always directs the ortho and para. It cannot direct the meta position. Why means if the electrophilic substitution takes place on this type of compound, and it can show the 4 resonance structures like this. First attack takes place, it can take an electron from the next carbon, rhenium ion formation, and delocalization of this rhenium ion takes place, and here rhenium ion takes place. So what happened here is nitrogen is having lone pair of electrons, it readily donates electrons to the benzene by the resonance effect, and this is a stable structure. Fourth one is formed in the ortho attack, whereas in the meta attack only 3 structures are formed, not a stable structure is formed. Why? This N is directly donating to the positive charged carbon, but in the meta formation that positive charge is not occurring at the exact this carbon which is containing NH2, and so this 3 only formed. Whereas in the para attack, same, this positive charge which is present on the carbon is directly attached to the NH2, so this positive charge is can be taken by the nitrogen and by donating the resonance electrons, and resonance effect can be showed. So that's why 4 resonance hybrid structures are formed. So when any ortho attack or para attack, 4 resonance structures are formed, and exactly that positive rhenium ion is mainly occurs at the carbon which is attached to NH2, and NH2 is giving electrons to the carbon by the resonance effect and by the double bond formation, more stable compound formation, more number of hybrid structures or formation takes place at the ortho and para position. That is not possible in the meta position. So that's why activating groups always directs the ortho and para attack. So they can produce ortho and para disubstituted compounds. The rhenium ion which are stabilized due to inductive effect, they are the substituents. The various resonance hybrids for the were as follows when methyl group is substituent. Meta is 2A, 2B, 2C. That is the resonance structure 1. These structures are more stable due to electron releasing, hence they attack make greater contribution to the resonance effect. See here, meta attack, whereas the meta attack takes place. So this is the CST group. This is by the inductive effect. During inductive effect also in the meta attack, that positive charge directly not comes into the methyl group which is attached to the carbon. Sides it is getting. So these 2A, 2B, 2C are formed in the meta attack. Whereas in the para attack, exactly the CST group which is attached to that carbon is getting the positive charge, and that is getting electron from the CST by the inductive effect. So the more stable structures are formed. So that's why they are more stable. So if the methyl group is present, they can be stabilized by the inductive effect. If the NH2 group is present, they can be stabilized by the resonance effect, and they can direct the ortho and para position. And because there is a more number of hybrid structures formation takes place, more stable structure formation takes place. Whereas in the meta attack, that stable structures are not possible. So that's why activating groups always directs the ortho and para. So coming to why deactivating substitutes direct the meta position. So here deactivating groups like NO2 is there. The electrophilic substitution takes place at the ortho position. Already the positive charge is mainly takes place at the carbon which is attached to NO2. NO2 is taking more electrons, already deactivating, and again this positive charge is mainly coming at this position only. So what happened? More destabilization takes place when the ortho attack takes place. In the same manner, coming to the meta attack, what happened? It can be skipping from this carbon which is attached to more deactivating group. It can be takes place at this position or this position or this position. So it can skip from that positive charge which is from the deactivating group. So that's why even though they are less hybrid structure formation takes place, that positive charge is not takes placing at the more deactivating carbon. So it is more stabilized condition. So in the meta attack, not more stabilized formation, more destabilized structures are not formed in the meta attack. So that's why here deactivating group is prefers the meta attack. Whereas in the para attack, what happened? Already that positive rhenium ion takes place at the directly attached carbon which is attached to NO2. already destabilizing takes place, and it is getting positive charge means it is a more destable state. This can